So this is the second problem based on the same paragraph in JEE Advanced 2017. Let me just recall what is being given to us. OX, OY and OZ are unit vectors. They are parallel to the sides of a triangle PQR. So we have a triangle PQR, and based on this we have got unit vectors. Okay, and what are these unit vectors? So this is the first unit vector, this is the second unit vector which is parallel to this, and then we have the third unit vector which is parallel to this. Okay, so this is X, OX, OY and OZ. Okay, now what is being asked? So it is being asked that we have to find out the minimum value of cos P plus Q plus cos Q plus R plus cos R plus, it's P again, okay, R plus P. Okay, now so this may be very well be written as minus cos R, and this may be written as minus cos P, and this may be written as minus cos Q. Yeah, right. Okay, so basically we have to find out what is the minimum value of this. So is there a way that we can represent minus cos R in terms of OX and OY? So minus cos R is this angle. Okay, so what are the two vectors that are coming over here? OY and, okay, so this OY is this one, and then we have OX, right? So if I take OX dot OY, okay, so if OX dot OY will be equal to the product of the magnitude, which is anyways 1, and so this is OX and this is OY. So we get cos pi minus R, which is minus cos R. Okay, so which means minus cos R, another way of writing it is OX dot OY. OX dot OY. And similarly, you can write it for cos P. So for cos P, what are the vectors involved? It is OY and OZ. So this becomes OY dot OZ. And finally, for cos Q, you can write it as OZ and OX. Okay, OZ dot OX. So how can one obtain this particular thing? We can very well write it as, so this is equal to OX plus OY plus OZ the whole square. Okay, remember these are the vector things that we are doing over here, and minus, so what is the thing that we need to do? Minus of the sum of the squares of all these things, right? So that is OX square minus OX square plus OY square plus OZ square. Okay, remember that whenever we are writing down square, it is actually taking the dot products. Okay, divided by 2. Okay, so we are just making use of the algebraic identity for a plus b plus c the whole square. So this is a plus b plus c the whole square is equal to a square plus b square plus c square plus twice ab plus bc plus ca. That's exactly what we have made use of here. Okay, so now have a look at this particular thing. All these things are fixed. This is 1, this is 1 and this is 1. So we cannot do anything with respect to this term. Only thing we can do is we can minimize this expression. And what is its minimum value? Since it is a square term, its minimum value is obviously equal to 0. Okay, so this is its minimum value is 0, and this value is minus 3 upon 2. So the minimum value is minus 3 upon 2. And when does this happen? Although it is not asked in this question, it's only asked for the minimum value. So the minimum value is minus 3 by 2. But if you want to know when does this happen? It happens when OX plus OY plus OZ is equal to 0. That is, the sum of these 3 unit vectors, it should be equal to 0. And when does this happen? This happens only if the angle between each of them is equal to 120 degrees, right? So this is 120 degrees. And when does the 120 degree happen? When this triangle PQR happens to be an equilateral triangle. Okay, so we can also say that the minimum value is obtained or attained when triangle PQR is equilateral. Okay, So, a nice problem. It involved some kind of vector algebra and realizing the fact that the sum of the and a basic inequality that the square is always non-negative.